Hey everyone, welcome back. Ready for another deep dive?
Always ready.
Awesome.
Ah.
Today we're going deep into reasoning with foundation models.
Oh, yeah, this is a hot topic.
For sure.
Yeah.
We've got some excerpts from a research survey paper to guide us. By the end of this, you'll have a solid grasp of how these AI models are changing the game, like across so many different fields.
It really is mind-blowing stuff. We'll break it down so everyone listening can understand not just what these foundation models are, but also, like, what they
Yeah.
can do and why it all matters, really, from, everyday life to the future of, like, scientific discovery and research.
Okay, so first things first. What exactly are we talking about when we say foundation models? It sounds kind of big, right?
It is kind of big. Well, imagine an AI that's not just good at one thing, right? But
Yeah.
can do all sorts of things like language, images, logic problems, all in one system. It's basically a foundation model in a nutshell. They're trained on huge amounts of data, making them super versatile.
So way more than just like a simple chatbot then, right?
Oh, yeah, definitely.
I'm looking at this graph from the research, figure 4, and wow, the amount of research in this area has just exploded in the past couple of years.
Absolutely. There's a ton of excitement around foundation models because they have the potential to completely revolutionize how we even think about AI. It's like we've moved beyond just, pattern recognition. Now we're into a world where AI can actually like reason and problem solve.
Okay, now that's interesting. But reasoning can mean a lot of different things.
Yeah.
How are the researchers defining it when it comes to, these models?
Yeah, that's a good point. There are a bunch of ways these models can reason. Some use deep learning, basically mimicking the way our brains work,
Right.
right? Others use a more structured, logic-based approach. And then there are some that actually combine both.
So multiple paths to get the AI thinking, right?
Exactly.
The research paper mentions like a bunch of different reasoning types, like backward and forward, single step and multi-step. I'm not sure I totally follow that, to be honest. Is there a simple way to think about these different approaches?
Sure, basically it's about how the AI reaches a conclusion. Think of it like solving a puzzle. Some models start with the end goal in mind and kind of work backwards. Other models will take things step by step, gathering information along the way.
Okay, that actually makes sense. Now, this figure 2 from the research paper, it really lays out all the different tasks that foundation models can tackle. It's honestly pretty mind-boggling. We're talking about common sense reasoning, math problems, logic puzzles, even understanding images and
I
sounds.
know, right? And what's really cool is how some of these tasks really do mimic like human intuition in a way we haven't seen before in AI. For example, there's physical common sense reasoning. Imagine an AI that actually understands like gravity, friction, all those basic laws of physics.
So if I drop my phone, this AI wouldn't just register the image of it falling, it would understand why it fell.
Exactly. That type of understanding is a huge step forward. And the implications, wow. Robotics could be revolutionized. Machines could navigate the real world way more effectively. Then there's spatial common sense reasoning. That's the ability to understand where objects are in relation to each other.
Like the AI wouldn't just see a cup and a table, it would understand that the cup is on the table.
Exactly. And it might even predict what happens if you bump the table, like, will the cup fall off? These are things that we as humans do without even thinking about it, right? But for AI, this is a major, major breakthrough.
Okay, this is honestly blowing my mind a little. I'm also seeing automated theorem proving on this list of tasks.
Yeah.
That just sounds so complex. What kind of impact could that have?
Oh, it's huge. Think about all the software and hardware we rely on every day. Automated theorem proving could let AI make sure that these systems are free from bugs and vulnerabilities.
Like that famous Pentium bug that cost Intel a ton of money. If we could catch those kinds of errors before they cause problems, oh man, that would be huge, especially in areas like cybersecurity.
Absolutely. So you can see why there's so much excitement around foundation models. They're not just like, writing poems or playing games. They have the potential to change how we approach some of the most challenging problems we face.
Okay, I'm officially on board with the foundation model hype. But with all this amazing stuff they can do, it makes you wonder, how do they actually learn to reason? What's happening under the hood?
Now that's the million-dollar question. And the research paper actually lays out some of the key techniques. One important one is alignment training. It's basically making sure that the AI's goals are the same as ours, like teaching it to play by our rules.
That sounds pretty crucial,
Yeah.
especially if we're talking about AI that can, reason and make decisions on its own. We don't want it going all rogue on us.
Nope, definitely not. Another important technique is called in-context learning. Imagine showing someone a few examples of how to do something. and they just pick it up from there. Foundation models can do that too, which is amazing.
Kind of like how we learn as humans, right?
Yeah.
You show someone how to tie their shoes a couple of times, and they get the idea.
Perfect analogy. And choosing the right examples is super important. The research calls it demonstration example selection. It's like choosing the right study materials to help someone learn effectively.
I could definitely see how that would make a big difference. Okay, the paper also talks about these things called autonomous agents. Now, that sounds like something right out of science fiction. What's the deal there?
Well, think of it this way. We've got this foundation model, this super smart AI brain, right? Now we put that brain into a virtual body, an agent that can, interact with the world.
So it's not just thinking and reasoning, it's actually taking action.
Mhm.
That's exciting, but also a bit, kind of intimidating.
Yeah, for sure. And there are some cool examples of how these agents are being used in virtual worlds, like Minecraft. They can navigate, they can solve problems, even interact with other players, and they do it all through language.
Wow. I can see how that could go way beyond gaming, though. Imagine AI agents that could, help with research or do customer service, even help manage our daily lives.
Exactly. And this is just the beginning. As these agents become more sophisticated, who knows what they'll be able to do.
Okay, hold on a second. Before we get too carried away with all the amazing possibilities, there have to be some limitations to these foundation models, right? They can't be perfect.
Oh, you're absolutely right. As amazing as they are, foundation models are still, kind of new. There are definitely some challenges. One big one is something called hallucination.
Hallucination, like seeing things that aren't really there, that doesn't sound good.
No, it's not about visual hallucinations. It's when the model creates information that's not actually true.
Yeah.
Not based on the data it was trained on. It's basically making stuff up.
Yikes. That could be a problem, especially if we're relying on these models for important things. Imagine an AI in healthcare, like hallucinating symptoms.
Oh, for sure. And then there's the issue of context window size. Basically, these models have a limit on how much information they can process at once. Like their short-term memory isn't that great. A larger window means they can consider more information, but it also takes more computing power.
So it's a trade-off between how much they understand and how much it costs to run them.
You got it. Researchers are working on ways to get around these limitations, but it's important to be aware of them as we explore what foundation models can do.
Okay, this deep dive has been absolutely incredible. We've covered so much: what foundation models are, how they learn, some of the challenges they face. But I got to know, where does all this lead? What does the future hold for this incredible technology?
That's what we'll be talking about in the next part of our deep dive. We'll be looking at all the cool research that's happening, from making these models easier to understand to the mind-blowing potential of, those autonomous language agents, and how they could totally change scientific discovery.
All right, looking forward to it.
Welcome back, everyone. So you've got a pretty good idea of what foundation models are, how they reason. Now let's take a peek into the future. What's next for this whole field? It's moving so fast.
Yeah, I'm super curious about that. Where could this tech lead us? What are researchers working on right now, to make these models even more powerful and make a real impact?
Well, one really exciting area is this thing called interpretability and transparency. Right now, foundation models can be a little bit like a black box. They give us answers, solve problems, but we don't always get how they got there.
It's like having a friend who's amazing at math, but they can't explain how they do it. Frustrating, but also kind of cool.
Exactly. So researchers are trying to make these models more transparent, like opening up that black box, shining a light on how they make decisions. This is really important if we're going to trust them and use them the right way.
I can see that, especially if we start using them in things like healthcare or finance, right? We gotta know why they're making the choices they make.
Absolutely. Another area that's getting a lot of attention is autonomous language agents. We talked about those a little bit before, but let's dig in a bit more. Imagine an AI that can understand and reason, but can also interact with the world through language.
So not just understanding, but actually using language to talk, get information, even take actions. That's next level stuff.
It is. And the research mentions some really cool examples of these agents in virtual environments like Minecraft. They can navigate, solve problems, even interact with other players, all through language.
I can see that going way beyond games, though. Imagine AI agents helping with research, doing customer service, even helping us manage our lives.
Exactly. And we're still in the early stages. As these agents get more and more advanced, who knows what they'll be able to do?
This is mind-blowing stuff. But it also makes me think about the potential impact on science. The research talks about how foundation models could, Revolutionize scientific discovery. That's a big statement. How could they change fields like medicine or bioinformatics?
Well, imagine an AI that can analyze tons of scientific papers, find patterns we humans might miss, and come up with hypotheses that lead to big breakthroughs, like new disease treatments or new drug development. We're already seeing some of this potential.
That's wild. So we could have AI helping doctors diagnose illnesses,
Yeah.
even create personalized treatment plans. The possibilities are insane.
And it goes beyond just medicine. Bioinformatics is another field that could be completely transformed. The research talks about AlphaFold, a foundation model that's made huge progress in predicting protein structures. That's a fundamental problem in biology.
Wow. If AI can help us understand the building blocks of life better, that could lead to so many breakthroughs in drug discovery, personalized medicine.
Exactly. And we're just scratching the surface here. Foundation models could change how we understand the universe, speed up scientific progress in so many ways.
Okay, so we've talked a lot about what these models can do, but I'm also curious about how we create them in the first place. How are these powerful AI systems trained? What makes them so smart?
Training a foundation model is kind of like baking a really, really complex cake. You need the right ingredients, the right tools, and a lot of patience. One of the most important ingredients is data. These models need massive amounts of information to learn.
So we're talking about feeding them everything: books, articles, images, scientific papers, like giving them a crash course in everything humans know.
Yeah, pretty much. The research mentions some of the key data sets they use, like the pile, this massive collection of English text, and ImageNet, a huge data set of images with labels.
But it can't just be about throwing data at them, right? There's got to be a way to make all that raw information into something useful.
You're right. Think of it like building a house. You need a blueprint, a plan that shows how everything fits together. That's where network architectures come in.
So this is about how the model is designed
Yeah,
to process all that data and learn from it.
exactly. One really famous architecture is called the transformer. It's been incredibly successful in natural language processing, and it's a big deal in foundation models, too.
Oh, I've heard of transformers.
Uh,
They're behind some of those really impressive language models we've seen.
that's right. But there are other architectures, too. Each one has its own strengths and weaknesses. It's about finding the right tool for the job, depending on the data and how complex the task is.
So we've got the data, the architecture. What's the next step in training?
That's where fine-tuning comes in. Imagine you have a multi-tool, like a Swiss Army knife. Fine-tuning is like sharpening one of the blades to make it perfect for a specific task.
So taking this general AI model and making it excel at something specific, like really good at one thing.
Exactly. And there are a bunch of different techniques for fine-tuning. Each one has its own advantages and disadvantages. The goal is to find the most efficient way to get the model to perform its best for a specific job.
It sounds like training these foundation models is a super complex process, like balancing a lot of different things to get the best results.
It definitely is. And it's an area where there's a lot of research happening. New techniques are being developed all the time. But one thing's for sure, the effort is worth it. These models have incredible potential to change so many aspects of our lives.
Okay, we've covered the data, the architecture, even fine-tuning these models. It's a lot to take in, but it's clear building these things is, well, complicated. But there's another piece of the puzzle I'm thinking about: alignment.
Yeah, you're right. Alignment is key. It's about making sure these AI systems, which are super powerful, are aligned with human values, our goals. We want to make sure they're working with us, not against us.
Right, exactly. We wouldn't want to create this super intelligent AI that doesn't, get our values or understand the things that are important to us.
Exactly. It's like, think of it like teaching a child, right and wrong, safe and unsafe. We need to make sure these models are making choices that benefit us, all of humanity, not harm us.
So how do researchers actually do that? Teach an AI about values?
Well, it starts with the data. The models have to be trained on data that reflects those values, right? So that might mean carefully choosing what they learn from, texts that, show ethical principles, or even getting feedback from humans, experts who can tell us what good behavior looks like.
So it's not just any data, it's got to be the right kind of data.
Yeah,
Data that teaches the AI to, make good decisions, ethical decisions.
you got it. And there are some pretty cool techniques for doing this. One is called supervised fine-tuning. That's where you train the model on data that's been labeled to show what we think is the right way to act.
So, showing the model a bunch of examples and saying, this is good, this is bad.
Exactly, but it's more than just basic examples. Researchers are also using things like human preference training. That's where people, actually rank different outputs from the model based on how well those outputs match up with human values. That kind of feedback is super valuable.
Wow, it sounds really complex, but it's also, reassuring knowing that there's so much effort going into making these models safe.
Yeah, absolutely. And things are always changing, always improving. Researchers are always coming up with new ways to make alignment training better.
This all makes me think about, well, safety and security. How do we make sure these AI systems aren't, misused or exploited?
That's a big one for sure. We have to be very careful about potential problems like bias. Bias can creep into the models through the data, right? If the
Right.
data itself is biased, the model can end up making biased decisions.
So again, it comes back to using good data, diverse, representative data.
Exactly. And then there's the risk of, well, attacks. Hackers might try to mess with the model, change how it behaves, or even try to steal information. It's like a whole cybersecurity arms race.
Mm.
Researchers are constantly working to protect against these attacks.
It's like a never-ending game of cat and mouse, huh?
Pretty much. But it's a game researchers are, taking very seriously. They're finding new ways to make models stronger, more resistant to attacks. It's a huge area of focus.
And then, of course, there's privacy. These models use so much data. We got to make sure all that data is being used responsibly.
Absolutely. Protecting privacy is super important. Researchers are looking into techniques like differential privacy and federated learning. These try to protect sensitive information, but still allow the model to learn.
So it seems like there's this whole world of research and development that's focused on, well, the ethics of all this. It's not just about making the models powerful. It's about making sure they're used for good.
Yeah, you got it. It's a really interesting field. And it's changing fast. As these models get more powerful and become a bigger part of our lives, it's an ongoing conversation. How do we make sure they're developed and used in a way that's, responsible?
Well, this has been an amazing journey from the basics of foundation models to like all this mind-blowing potential
Yeah.
and the challenges, of course.
It's been great exploring this with you. And remember, we're just getting started. There's so much more to come with these models.
So to all our listeners out there, we'll leave you with this. As foundation models keep evolving, how do you see them changing your world, your work, your everyday life? What possibilities excite you? What worries you?
Keep learning, keep asking questions. The future of AI is full of potential, and we're all part of it now. Thanks for joining us on this deep dive.